We've now wrapped up most of the Ethereum side of our application. We're still going to come back and make one or two quick changes to our contract, but in general, I think that the campaign is at a pretty good spot right now. We're now going to pivot a little bit and start discussing the web application that we're going to build so that people can actually create campaigns and donate to them from a web browser. Before we start that, however, I want to give you a quick disclaimer here. I know that if you're here in this course, you came to learn specifically about Ethereum. In the application we're about to start working on, we're going to spend a lot of time talking about React and a lot of associated React libraries. So you might be thinking, Steven, I came here to learn about Ethereum. I don't want to learn about React at all. Why are we spending so much time on React? Well, remember what we said much earlier when we were working on the lottery application. At the end of the day, Ethereum is not just a standalone technology that operates without anything else. In reality, we use Ethereum along with many other libraries. And we have to use these other libraries so that users have a UI to actually interact with. So even though you're here to learn about Ethereum, I know it might be frustrating to spend time learning about React at the same time, but really we have to know about how to use Ethereum with these Vue libraries, because otherwise we just can't build an actual application. All right, so that's my quick disclaimer. Hopefully the React stuff is not that painful for you. Okay, so with that in mind, let's take a look at some mock-ups that are going to show you exactly what we're going to try to build. So at the end of the day, we want to make more or less a Kickstarter clone, something that allows people to browse open campaigns, contribute to them, create campaigns, create requests, everything that we put together inside of our contract. Essentially, every aspect of our contract needs to have some visible feature in the application that we're going to build. I've got on the screen right here the landing page for the application we're going to make. Now, when we actually make this thing, it's going to end up looking quite nice. And I think you're going to enjoy the styling that we end up with quite a bit, like the actual CSS. But for the mockups, I'm going to keep it just kind of like diagram in nature. So at the very top, we're going to have a header. We're going to call this application CrowdCoin. I know that we named the project folder that we're working from right now Kickstart, but that's kind of a boring name. Let's use CrowdCoin. I think that's just a little bit more fun. So at the very top, we'll have the name of our application. We'll have a link that will take the user to a list of all the different campaigns that have been created, and a button that the user can click to create a new campaign as well. This is the landing screen that a user will land at when they first come to our application. When they first come to our application, we'll show them a list of all of our open campaigns. So going down the page right here will be a list of all the campaigns that have ever been created. A user can then click on one of these campaigns to view some details about it. And on the right-hand side, if a user wants to create a new campaign, they can click on the Create Campaign button. So notice that we have the ability to create a campaign twice on here, both this button and the plus up in the header as well. I know it's a little bit duplicate, but whatever. Just make sure that it's really easy for people to create a campaign. So there's still a couple of other pages that we need to look at, about 4 or 5 in total. Once a user decides to create a campaign, we'll take them to a simple screen that shows a form. There's really not a lot of information that we need from a user when they try to create a campaign. Really, we just need the minimum contribution amount. So the user will enter that into a text input, and then they should click on the Create button. When they click on the Create button, as you and I very well know by this point in time, this will run the Create Campaign function on our Campaign Factory contract. So the user clicks this, and then they wait around for 15 or 30 seconds or so for the campaign to actually be created. Now that definitely brings up the topic of how we're going to handle these big pauses as we wait for transactions to be processed. So as we are building this application, we're going to start to investigate some different patterns to make sure that a user is very much aware that, hey, when you click this button, you have to wait for 15 seconds. Like, we want to make sure it's really clear to the user, hey, we're doing something here, just hold on, we're processing the transaction. After a user creates a campaign, we should then make sure that they have the ability to look at some details about the campaign. So this is going to be a page right here that shows details about a very particular campaign that has been created. On the left-hand side, I want to show some statistics about the campaign. So maybe its balance, the amount of money that has to be contributed to be considered a approver, the number of requests that have been created, and the number of people who have already contributed to the campaign. On the right-hand side, we'll show a little form that allows a visitor to contribute to the campaign. So they'll enter some money and click on the contribute button. And then at the very bottom left-hand side, we'll also show a little link that someone can click on to be taken to another screen where they can look at all the pending requests that are tied to this campaign. So that screen is going to look a little bit like this. So this is going to list all of the pending requests for one particular campaign. We're going to put together a little table that shows the ID of a request, its description, the amount of money that we're trying to transfer, the recipient, the approval count, and notice that the approval count is going to have both the number of positive votes on this request out of the total number that are tied to our contract. So in order for this request right here to be approved, it's probably going to need at least 151 out of 300 votes for it to be finalized. And then on the right-hand side, the last two columns here, will show two buttons that can allow any contributor to either approve, and you know what, I marked this as reject. We don't have reject, that's my mistake. This should say finalize. Yeah, so we can either approve or finalize a request. And of course, we'll probably want to do some amount of validation when we show these buttons. Like something to say, hey, if you're going to click this, maybe we only want you to be able to finalize a request if you are the manager and there are an appropriate number of approvals. All right, now the very last thing is the add request button right here at the top right. So if a user clicks on this, we'll take them to a form where they can attempt to create a brand new request. So they should be able to enter a description, the amount of money that they want to transfer, and then the recipient. And as we've discussed many times, this is a form that should probably only be able to be submitted by the manager of the campaign. Because remember, only the manager can create spending requests. All right, so that's pretty much it. That is all the UI that we're going to build. Now, the reason I put that disclaimer at the start of this video saying, hey, I know you're here to learn about Ethereum, not React. Well, you know, we've got like 5 pages that are somewhat complex in nature. And so we're going to be spending a lot of time putting together this application. And so you probably will think at some point, Steven, I am so tired of this React stuff. But honestly, I can't tell you how excited I am about this application because this really is so cutting edge in the world of Ethereum. Like what you're going to learn right now, building this application, is so incredibly cutting edge. This stuff just does not exist right now. There's not a lot of applications that are so complex that work with Ethereum. So I know, hey, the React stuff might be painful, but you have no idea how valuable the skills are that you're going to pick up as you're building this app. I really think that at the end of this course or the end of this application, you're going to be really happy with how this project turns out. Really. All right. Now, just one last thing I want to very quickly mention. As we've seen, there are like 4 or 5 different pages here. And so we need the ability to somehow navigate between all these different pages. And more importantly, perhaps, we need to somehow figure out what URL a user is going to visit to show each of these pages. So I put together a little table of some of the possible routes that I think that a user should be able to visit inside of our application. So in other words, if a user comes to our app, and let's say we register our app at crowdcoin.com. So if they navigate to crowdcoin.com, that would correspond to a path of /, as in something like crowdcoin.com/, right? That's our root web page, the root page, the first page a user sees when they visit our application. So whenever a user goes there, we should probably show them a list of campaigns, right? That's going to be our home page. We're going to show them all the campaigns that have been created. Then I'm going to suggest that whenever a user goes to the URL campaigns/new, so basically crowdcoin.com/campaign/new, we should show them the form to create a campaign. Now here's where things get a little bit interesting. When a user goes to campaigns/some address, we're going to assume that they want to get some details about the campaign at that address, like the campaign that is at address 0x8147 And of course, there's a lot more characters in the address than just that. So in other words, if the user goes to campaign/0x8147AB, whatever, yada, yada, we should attempt to load up this campaign and show details about it to the user. And then I think you get the pattern here. If a user goes to campaigns, address/requests, we want to show the table of requests. And if they go to blah, 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 request/new, we should show the form where the user can create a new request for that particular campaign. So I just want to make sure it's really clear. These are all very separate pages that a user is going to be looking at and navigating between inside of our application. And the URL is going to be very tightly coupled to what content we want to show to the user on the screen. All right, so that's pretty much it as far as mockups go. Now, we do have to talk a little bit about the tech stack that we're going to use for building this application, because it's going to be a little bit different than what we had done back on the lottery application. So quick pause, and we'll talk about our tech stack in the next video. In this video, we're going to have a short discussion about the tech stack that we're going to use for our campaign, or crowdcoin, I guess is what we're going to call it now, application. In previous videos, when we worked on our lottery application, we had used Create React App, right? We used that tool to generate a new React project. That gave us a place where we could write some React components, we could install some third-party modules like the Web3 library, and then we could get some content to appear in our user's browser. Create React App is really a tool for making a rather simple or straightforward React application. Certainly, we could use it to make more complex stuff, but out of the box, it's really about just helping you get started with a simple boilerplate setup. Now, the downside to Create React App is that out of the box, it doesn't really include anything to help you with navigation, like showing different pages to a user. And it doesn't really have anything out of the box to help you with data loading or all these other tools as well. So Create React App is great. It's a great place to get started, but what we're building needs something a little bit more full-featured. So rather than using Create React App, we're going to use a slightly different tool to start up our project. So you and I are going to be using something called Next.js. Next.js is a framework that wraps up React. Remember, React is all about showing content or HTML to a user. Next.js takes React and builds a bunch of functionality around it. A lot of fancy features are included with Next.js right out of the box, so we don't have to do any additional setup to get these other features working. And these are features like routing. And when I say routing, I'm talking about showing multiple pages to a user, like taking a URL and deciding based on that what content we should show to the user. It also has built-in support for server-side rendering, which is something that we'll talk about in a little bit. And this is something that is very, very relevant for an Ethereum application. And again, we'll talk about exactly why that is. And then finally, as part of the developer experience, it has something called Hot Module Reload, which basically means that it will just update code inside of your application a little bit more easily. And it's really just something that is about the developer experience. At the end of the day, Next is something that we can use to make a React application that has great support for showing multiple pages to a user. And that's exactly what we're trying to do here, right? We want to make one web page that shows a list of our campaigns. We want a page for creating a campaign. We want a different page for details, and so on. We want different pages for each of those different features. And so Next.js makes that really easy to put together. And as soon as we install Next.js, I'll give you a very quick demonstration that makes it very clear exactly why it's so easy to get started with multi-page applications. Now, I'm not going to show you too much of the Next.js documentation directly. I do want you to know that at any point in time, you can always go and refer to the documentation if you want to get a better idea of how something works. You can pull up the documentation by just doing a Google search for Next.js, and you're going to be looking for its GitHub repository. So for me, it's the first result here. For you, it might be a little bit later on down. But basically, if you go to the repo, right on this front page, you can scroll down, and it's got a tremendous number of resources to help you understand about exactly how all these different things work. So of course, as we start using this, I'm going to be telling you exactly what every single line of code does, But again, if you want to get a little bit more information about anything that's going on, feel free to pop over here and read about the documentation a little bit. All right, so again, we're going to be using Next.js. When I built this application, like before I made this course, before I recorded this video, just so you know, I built this application very much like the lottery app. I built it like 4 times with 4 different tech stacks. I used Create React App, I used vanilla HTML, I used Next.js, and I don't know, I did some other variation as well. And so I built this app 4 times and I took 4 different approaches. And I found that using Next.js was by far the easiest and most direct approach. And it made working with the Ethereum side of our application really easy and straightforward. So I'm not picking Next here just to use like some arbitrarily fancy framework or anything like that. I really truly believe that this is one of the best approaches for building an Ethereum application. So there is some reasoning behind this. Anyways, let's take a quick pause right now. We're going to come back to the next video and we're going to start setting up Next inside of our application. Now that we've got a better idea of what Next is, let's install a couple of dependencies into our project, and then we're going to start discussing exactly how Next works. I'm going to flip on over to my terminal, and over here I'm going to make sure that I'm inside of my Kickstart directory. I'm then going to install a couple of different modules. So I'll write out npm install --save. We're going to get Next, and I want a very specific version of Next just to make sure that you and I are using the exact same version. So we're going to say Next at 4.1.4, like so. We're also going to install React and React-DOM. So 2 separate libraries here. Let me increase the font size so you can see those all on one line. There we go. So Next, React, and React-DOM. All right, so let's let that do its thing. And while that installation is running, I want to show you a quick diagram or two that's going to give you some initial idea of how we organize code in a Next project. All right, so over here on the left-hand side, we have our project directory. We already have a couple of different files and folders inside of our project directory. I'm not showing those existing files or folders here. I'm only showing 2 relevant folders that I want you to be aware of as far as Next goes. So the first thing I want you to know is that as soon as we start running Next inside of our project, a new directory is going to be created automatically. This new folder called .next is essentially where the magic happens, so to speak. Next is going to automatically create this folder and manage all the contents inside of it. This is where Next does a lot of its build steps, a lot of serving up of different files and folders, and all that kind of good stuff. So I just want you to be aware that you're going to see this folder appear, and it's going to contain a lot of behind the scenes configuration that is going to kind of control how our application actually works. The other big thing to be aware of is to understand exactly how Next handles navigation, or the creation of new pages that can be visited inside of our application. So you and I are going to make a very special directory. This directory is going to be called Pages. Whenever Next starts up, it's going to look for a folder called Pages, specifically Pages. So please do use this name when we actually create this folder. Inside of Pages, you and I are going to create a bunch of different React components. Every single file that contains a React component that we place inside this directory right here is going to automatically be turned into a web page that we can visit inside of our application. So for example, let's say that you and I create that Pages directory, and then we create 2 files inside there. One being show.js and the other being newcampaign.js. And let's imagine that both these files right here create a React component. As soon as Next starts up, it's going to look into this Pages directory, and it's going to look at all the different files that exist inside of it. It's then going to see that there are 2 separate React components inside there, inside of 2 different files. It's then going to take those file names, so the name show and the name new campaign, and it's going to create 2 new visitable routes, or like actual web pages that people can visit inside of our application, with the name of show and new campaign. So in other words, if a user came to our application that was running Next with these 2 pages, they would be able to visit crowdcoin.com, that's a tongue twister, /show, because that's the name of this file over here. And they would also be able to visit crowdcoin.com/new-campaign because of the file name over here. Whenever a user goes to this route or this route, they will automatically see the show page, or excuse me, the component defined inside this file appear on the screen. And the same thing for new campaign as well. So at a very low level, this is how the routing system inside of Next works. Basically, we make React components inside the pages folder right here, and they automatically get turned into pages that our users can visit. Given that you and I have a total of like 4 or 5 different pages that we want to show to our user, right? We've got like the campaign list page, we've got the campaign creation page, all these different pages that we want to have the user be able to visit. We're definitely going to take great advantage of this pages system. So we're going to make one separate component that's going to display each of the different pages that we had previously discussed. All right, if I flip back over to the terminal, it looks like my installation process is complete. So let's take a pause. We'll come back in the next video, and we're going to start to implement our first pages. So let's take care of that in the next video. We just spoke about the pages concept of the Next.js framework. In this video, we're going to try to create 2 new pages that we can visit inside of our project, and then we'll start up the Next framework and make sure that they are in fact pages that we can visit. Inside my Kickstart directory, I'm going to make a new folder that's going to hold all the different pages that our users can go to. So I'm going to make a new folder, and I'm going to call it Pages. Again, I can't say it enough. Please call this thing Pages. If you call it anything else, it's not going to work. Next specifically expects to see a folder called Pages. Then inside of here, we'll create 2 new files. The first one we'll call show.js. And then the second one we'll call new campaign.js. And we'll keep it all lowercase for right now. We're going to eventually delete both these files. For right now, I just want to give you a very solid example of how Next.js does its routing. Now inside of each of these, we're going to create and export one single React component. So up at the top, we're going to import React from React. We'll then make a functional component and immediately export it from this file. So I'll say export default. I'll place an arrow function, and from this thing I will return an H1 that says this is the new campaign page. I'm then going to copy this. I'm going to go over to my show file, so show.js, and I'll paste this in. And we'll update to the H1. We'll change it over to welcome to the show page, like so. All right, so let's now attempt to start up Next.js, and then we're going to verify that we can visit both of these pages inside of our application. To start up Next.js, we have to create a new script inside of our package.json file. So I'm going to open up my package.json file. I'm going to find the scripts section inside there, and I'm going to add another entry to this thing. We're going to create another script called dev, and whenever we run this dev script, we're going to execute the command next dev, like so. All right, so let's now go over to the command line, and we're going to execute this command right here in order to start our project up, and then we should be able to verify that we can visit these 2 separate pages. So back at the command line, again inside of my Kickstart directory, I'm going to run the command npm run dev. Now we're going to wait just a minute or 2 for this command to actually boot up. It's going to process all the different files and folders inside of our project directory, and then in a couple of seconds we should see a message that says ready for localhost :3000. So we're going to open up our browser now. We'll open up a new browser tab, and I'm going to attempt to visit localhost :3000. Once we go here, it's going to take just a moment or 2 to load up for the very first time, but very quickly we'll see a message on the screen that says 404. This page cannot be found. So we just attempted to visit a URL that does not have any corresponding page inside of our pages directory over here. Let's now try to visit the show route and the new campaign route. And when we do so, we should see this component and this component appear on the screen. So we'll go to localhost 3000/show. And again, we wait a second or two for everything to load up. And then we very quickly get welcome to the show page. Cool. Likewise, if we go to localhost 3000/new campaign, we'll see this is the new campaign page appear on the screen as well. That's pretty much the basics of Next.js routing. And believe it or not, there's not too much to Next.js beyond this. Well, of course, there's some very important details, but at the end of the day, when we start using Next, the thing to keep in mind is that for every page that we want to create, we're going to make a new React component inside this pages directory. And we're going to make sure that the name of the component itself corresponds to the page or the URL that we want to have automatically generated for us. So that's a very simple introduction to Next, but of course we're probably going to have to figure out some much more complex things as well eventually. So let's pause right here. We'll continue in the next video and we're going to start moving forward with our application. In the last video, we got a quick demonstration of how routing works with Next.js. So we place different files into the pages directory and poof, we're all of a sudden able to visit those inside the browser. Now that we have a better idea of how navigation works, let's start working on our first real page of our application. The first page that I want to work on is going to be the one that shows a list of all of our open campaigns to our users. So whenever a user comes here, they should see all these different campaigns listed down the screen. A user should see this page whenever they visit the root route of our application. So if they went to crowdcoin.com, yeah, we want to show this to them right here. Now notice the URL up here does not seem to have any named route attached to it. However, in the last video, we were just saying that the name of these components inside the pages directory will be used as the actual route. So how do we make a page that gets displayed at the root route of our application, where there is no little name on here that we can visit? Well, to do so, we can go back over to our code editor and we can rename one of these existing components to be index.js. With a file name of index, Next is going to assume that if someone ever visits the root route of our application, like crowdcoin.com, it will automatically show the index.js file. So let's take one of our two components here, or one of our two pages, and we're going to rename it to be index.js, and then we'll test that out inside the browser to make sure that it is displayed as the root page. So I'm going to take new campaign, I'm going to rename it, and I'm going to change it to index.js. Again, this is a special file name. If we have any component named index.js inside the pages directory, it will be used as our root route. Inside of index.js, I'm going to update the text in this thing to say this is the campaign list page, because that's essentially what we eventually want it to be. I'll then save this file. I'm going to make sure that my Next server is still running inside the terminal. And remember, if you ever stop it, you can start it back up again by running the npm run dev command. Now back inside the browser, I should be able to open up a new tab and navigate directly to localhost 3000. And then after a short pause, we'll see the this is a new campaign list page appear on the screen. Cool, so that's how we get some root route or some root component to appear inside of our application. Now eventually we want this thing to show a list of all of our different campaigns, right? That's going to be a somewhat involved process. So I took the liberty of putting together some steps that we're going to go through to eventually get a list of campaigns to appear on the screen. So here's the list of steps that I think you and I need to do. All right, so as you can see, we've got a little bit of a work ahead of us here. So the first thing we need to do inside of our application to enable us to get a list of all of our campaigns is to import and configure Web3. Remember, anytime we want to access some data from the Ethereum world, we need to make use of Web3 and we need to set up a provider with it. Recall that the provider is what Web3 uses to communicate with some external Ethereum network. In the short term, we are going to rely upon the provider that we get automatically from MetaMask. And remember, MetaMask automatically injects a provider into the page whenever it runs. After we set up Web3, we'll then tell Web3 that we have already deployed a copy of the Campaign Factory contract. Remember, we did that like 4 or 5 videos ago. So we're going to tell Web3 exactly what a Campaign Factory contract looks like. In other words, we're going to give it our Campaign Factory interface, and then we will also give it the address of the instance that we have already deployed. That will return to us a contract instance that we can then manipulate or access from inside of our application. So after we set all that stuff up, we can then use that factory instance to retrieve a list of all the different campaigns that we have deployed over time. At present, we have not used that factory to deploy any campaigns whatsoever. So the first time we had tried to get a list from this thing, we might get back an empty list. But there's a very easy way that we can pretty quickly create a new campaign instance, and we'll take advantage of that at that time so we can get some early content on the screen without having to create the form that is going to eventually make new campaigns for us. After we get that list of deployed campaigns from the factory instance, we can then use React inside of our application to show some information about each campaign. So specifically, show this list right here. Show the list of open campaigns to our users. All right, so that's pretty much it. Those are the steps that are ahead of us. It's definitely a good amount of work. So let's take a pause here, and we'll get started with configuring Web3 in the next video. In the last video, we laid out a to-do list of what we have to do to eventually get a list of campaigns on our screen. The first thing we're going to do is to create a new instance of Web3 that uses the provider that is given to us by MetaMask. We already went through this process once before, back on our lottery project. You'll recall that back on that project, we had imported Web3. We then used a provider to create a new instance, and then we exported it from that file we had created. We're going to do the exact same thing here inside this project. Recall that we had said that all of our Ethereum related code is going to be placed inside of our Ethereum directory. So I'm going to make a new file inside of here that we're going to use to create our new instance of Web3. I'm going to make a new file, and I'll call it web3.js. Inside of here, we're going to write some code that is basically the same thing that we did back on the lottery project. At the top, we will import Web3 from Web3. We'll then use this constructor to create an instance of Web3. So we'll say Web3 is new Web3, and then we're going to give it the provider that is automatically provided to us by MetaMask inside the browser. And we can get access to that by referencing window.web3.currentProvider, like so. Then down at the bottom, we'll make sure that we export this new instance. So we'll say export default Web3. Now just a couple of quick reminders in here. As usual, make sure that the constructor function has capital W's and that the instance has lowercase w's. The other thing that I want to mention is that we're currently making a very big assumption in saying that we think that MetaMask has already injected a Web3 instance onto the page. Now that definitely might not actually be the case. Especially for this application, we want to make sure that in the future, people who are not using MetaMask should be able to use this application just as well. However, if other users who don't have MetaMask installed are trying to visit our application, Web3 will not be defined ahead of time, and that's going to definitely throw an error for us. We're going to come back a little bit later, and we're going to make some improvements to this file to handle the case in which a user without MetaMask tries to visit our application. But for right now, we'll keep things a little bit more simple and straightforward, and we're not going to worry about that just yet. All right, so let's now save this file. And the next thing we need to do is to tell Web3 that we have already deployed a copy of the Campaign Factory instance, or excuse me, the Campaign Factory contract. Let's be precise with our terminology here. So for this, we're going to create another separate file, and inside there, we will import Web3. We will then tell Web3 about that contract, and we will provide the address to it. In the same exact way that we now have a file that we can easily import to get access to Web3, the idea here is that by making a separate file that is going to house our factory contract, we can import that contract or that file into any other location inside of our project and instantly have access to a already deployed version of the factory. Now I'm using a lot of words right now that might not be making a lot of sense. So let's just write some code and see what this looks like. Inside my Ethereum directory, I'm going to make a new file and I'm going to call it factory.js. Inside of here, we're going to import the copy of Web3 that we just created. So we'll say import Web3 from ./Web3. Notice that we are using lowercase here because we are not accessing the Web3 library. We're not getting the constructor here. We're getting the instance that you and I just created. Then right underneath that, we're also going to import the compiled contract that is placed inside of our build directory. So remember, anytime that we want to tell Web3 about a already deployed contract, we have to give Web3 that contract's interface, or ABI. And the ABI is defined inside of the campaignfactory.json file. So we will import campaign factory from ./build campaignfactory.json, like so. Next, we're going to create our contract instance that refers to this specific address that we had already deployed the contract to, and we'll export it from this file. So like I said, if we ever need to get access to our deployed factory, all we're going to have to do is import factory.js. So we're going to say const contract. Actually, let's call it instance. Why not? Instance is new web3.eth.contract. Remember that the first argument to this is going to be our contract ABI, and that exists inside of our campaign factory variable right here, because this is the compiled contract that we had written to that JSON file. So as the first argument, we'll give json.parse campaign factory.interface. And then as the second argument, we need to provide the address to that we already deployed our factory to. And we did that a couple of videos ago. You'll recall that we had saved that address inside the address file right here. So I'm going to go back over to this address file. I'm going to copy the address and I'll paste it in here as our second argument, like so. And then finally at the bottom, we can say export default instance. Oops, instance. No, one more try. There we go. All right, so I feel like at this point in time, we are writing code that probably looks familiar, but it might be a little bit confusing exactly why we're placing some code inside the factory file and some code inside of Web3. Like I have said several times now, the entire idea here is that if we need to get access to our deployed factory instance from somewhere else inside of our application, we won't have to go through this entire process of importing Web3 and the interface and get the address and all this stuff. Instead, all we're going to have to do to get a handle on our instance is import this factory.js file. And poof, there we go. That's our pre-configured instance of our campaign factory. So this is really just about kind of setting ourselves up for making life easier as we start to work on more advanced features inside of our project. So now that we've got this instance easily accessible, we can use that instance to retrieve a list of all of our deployed campaigns and then show that list inside of our React component. So let's start taking care of that in the next video. In the last section, we put together a little bit of infrastructure inside of our project. So we set up our Web3 instance, and we've also set up an instance for our campaign factory contract. As we said just a little bit ago, we have not yet actually deployed any instances of campaigns tied to our deployed campaign factory. In other words, right now on the Rinkeby test network, we have our campaign factory instance, but there are no campaigns tied to it whatsoever. So if we try to get a list of deployed campaigns, we're just going to get back an empty array. And as far as putting together this component to show a list of campaigns goes, well, an empty array is not that useful. So in this video, we're going to use Remix to reach out to our campaign factory and ask it to create an instance of a campaign. That will give us at least one campaign that we can work with, that we can fetch and then try to display on the screen. So essentially right now, we want to create a little bit of dummy data. That's pretty much what we're doing. So with that in mind, I'm going to flip back over to Remix. Now, I've kept Remix open all this time with my contract for the campaign factory and my campaign inside of it. If for any reason you might have closed Remix or you changed the contract or something like that, remember that you can always open up our backup, or I shouldn't even really call it our backup. It's really our written file inside of our contracts directory called campaign SOL. So you can copy everything inside of here and place it back into Remix, just in case you lost this code. All right, so once over here, we're going to use a little feature in Remix that allows us to interact with deployed contracts. On the Run tab, I'm going to make sure that I have my injected Web3 selected this time. And just to the right of that dropdown, I should see something that says Rinkeby. So if you don't see Rinkeby right here, if you see something that says main network or something like that, remember you can always open up MetaMask and make sure that you have the Rinkeby test network selected on this dropdown. Once you change it to Rinkeby, you can then refresh Remix, and once you select injected Web3 here again, you should see Rinkeby appear. So what we're going to do is we're going to select our dropdown and change it to campaign factory. Remember just a little bit ago when we were testing out our campaign deployments through Remix, we used this @address tool right here that allowed us to take a contract that had already been deployed and sort of get a handle onto it through Remix directly. All we had to do was enter in the address of the contract that we wanted to reference. So we're going to get the address of the campaign factory that you and I deployed a couple of videos ago. We're going to enter it in here. We're going to load up that instance into Remix, and then we'll be able to tell that instance to create a campaign for us. So this is entirely circumventing the path where we might have to, maybe you would have been thinking we had to put together the UI to create a new contract and all that stuff. Nope, no need to do that. We can use Remix to interact directly with the campaign factory. So the first thing we have to do is go back over to our code editor and get the address of our deployed factory. Now I've left around the address file that contains the address that we had deployed the factory to a couple of videos ago. If you lost this address, remember we just made use of it inside of the factory.js file. And if for whatever reason you didn't copy it over here or whatever it might be, remember you can always redeploy the campaign factory by running our deploy script. All right, so back on track here, I'm going to copy the address. Then back inside of Remix, I'm going to paste the address into the @address bar right here. And then I'll make sure campaign factory is selected, and I'll click on @address. All right, so this right here is our deployed campaign factory on the Rinkeby test network. If we click on Get Deployed Campaigns, we should have an empty array of addresses because we have definitely not yet created a campaign. To create a campaign, all we have to do is enter in a minimum contribution value to the Create Campaign section right here, and then click on that button. Remember, when we click on this button right here, it's going to send an actual transaction to the Rinkeby test network. And because it's Rinkeby, it's going to take between 15 and 30 seconds to be completed. So I'm going to clear my transaction log over here just so I can monitor the transaction and make sure that it goes through successfully. Next, I'm going to put in a minimum contribution of 100. Remember, this is units of whey right here. So I'm saying that you must donate at least 100 whey into this campaign. And then I'll click on that button. When I click on it, MetaMask is going to appear, and it's going to try to confirm that we actually do want to execute this transaction. And yes, we definitely do. So I'm going to click on Submit. All right, so that basically is going to send out the transaction. And this is the part where we wait about 15 to 30 seconds or so. Now, no need to sit around and wait for this. I'm going to pause the video right now, and when we come back to the next video, we should see the completed transaction here in our log. So I'll see you in a minute. In the last section, we used the campaign factory to deploy a new campaign. If we now click on the Get Deployed Campaigns button, we should see the address of our newly deployed campaign appear. So now that we've got our campaign, we can go back over to our project where we can use our factory instance to get a list of all those deployed campaigns. And we're saying list right here, but as we well know, right now there's only one deployed campaign. Once we get that data, we can use a React component to display that list of campaigns on the screen. So let's get to it. Back inside of my code editor, I'm going to open up the pages index.js file. So here it is on the screen. Remember, this is intended to be where we display a list of all of the active campaigns. So inside of this file, we're going to want to use our factory instance to get a list of all those addresses and then use the React component to display them on the screen. Let's give it a shot. The first thing we need to do inside of here is make sure that we import our factory instance, which we've already created inside of that factory.js file. So I will import factory from up1 directory, Ethereum, factory, like so. Now we need some location to fetch this data. Right here we've got the factory instance, but we need to actually call our method getDeployedCampaigns off that factory at some point in time. For that, we're going to redefine our component right here from a functional component to a class-based component. When we do that, we can then make use of the lifecycle method component_didMount, which is a great place to load up some data inside of a React component. Once we do that data loading, we can then somehow render it out to the user so they can see that content appear on the screen. So let's replace this functional component with a class-based one instead. I'm going to say class campaign index. So that's just going to be the name of my component. I kind of picked it at random. There's nothing special about the name. Extends component, like so. We're using the component-based class here from the React library, so let's remember to import that from React at the top. Don't forget to get your curly braces on the import. Next, we can define our component_didMount method. We're definitely going to end up with some asynchronous code inside this method, so let's make sure that we mark this thing as being asynchronous. Then we can use our factory instance to call our getDeployedCampaigns function. So I'm going to call await factory.methods.getDeployedCampaigns.call. So this is going to retrieve an array of the addresses of all of our deployed campaigns. And right now there's just one, but hey, eventually we'll have many. We need to assign this to a variable, so I'm just going to say const campaigns is that, like so. And then I think for right now, maybe we should just add a console log and attempt to log out that list of campaigns, just to make sure that our component right here is working the way we expect. So I'll say console.log campaigns. Whenever we make a React component, we do have to return some JSX from the render method. So even though we're not going to make use of this data just yet, we do have to put out some minimum amount of JSX. Otherwise, we're going to get an error thrown. So just to make React happy, we're going to define the render method. And from there, I will return a div that says campaigns index. And again, this is just to get something on the screen so we don't get an error message. Now there's one last thing I want to tell you about this pages directory. We've had a couple of words about the pages directory, but last thing I want to mention about it is that whenever Next imports a file from this directory, it's always going to expect that that file exports a React component. So it's not enough that we just defined a React component inside of here. We have to actually export it from this file. Otherwise, Next is going to throw an error and say, hey, you didn't actually export a component from this file. So at the bottom, we'll be sure to add an export statement for the campaign index component that we just made. So I'll say export default campaign index. Now one quick thing I want to mention to you, the word campaign is very easy to misspell. It's really easy to actually type it out as basically campaign, like you see right here. So I do encourage you to do a quick check over this component and make sure that you have properly spelled campaign in all locations. Once you've got that done, we'll save this file and test it out inside the browser. Before we tab over to the browser, I want to mention that right now we are going to see an error message when we try to render this thing inside the browser. Okay, so I want you to just be aware we will see an error message. but that's totally fine. It's actually going to lead in very nicely to a very important topic that we need to discuss. So let's now flip over to the browser and see that error message. All right, I'll go back over to my localhost 3000. Over here, you might initially see a message that says nothing was returned from render. This is erroneous right here. So this is an error message that is being caused because of the hot module reload system that is included with Next. So this is not the error message we were looking for. The message that we really want to see will pop up after we try to refresh the page. So I'm going to click on reload, and then we'll see the message that we really wanted to see, which is window is not defined. Like I said, we definitely expected this, but it definitely is going to have a very nice segue into a very important topic that we need to discuss about next. So let's pause right here. We're going to come back in the next video and we'll talk about exactly why we are seeing this nasty error message. In the last section, we tried refreshing our application and we got a message that said window is not defined. In this section, we're going to talk about this error message and we're going to figure out why it's being thrown and how to fix it. This really cuts to the core of what Next.js is doing for us. So like I said in the last video, it's actually serving as a very nice segue into an important topic. So let's talk about what's going on. We're not going to directly discuss that error just yet. First, I'm going to give you a little bit of background information on Next, and then it'll be a lot more clear why we're seeing that error. Okay, so here's the background information you need to know. When we were previously working on our lottery project, we had made use of Create React App, right? Here's Create React App over here. We wrote some amount of React code, and we created a contract or two, and then eventually we got all that content to show up inside the browser. One thing I want to make sure is really clear is that when we were using Create React App, that server or that process that we were running inside of our terminal took all of the React code that you and I wrote and then served it up into our browser. So all Create React App did for us was take all the JavaScript code that we wrote and made it available to the browser. Our browser downloaded all that code as the React app. It then executed that code. Our React application boot up, and it displayed some amount of content on the screen. The key there is that the Create React App server, its entire purpose was just to serve up some JavaScript code. And it had no idea what it was really doing or what it was serving. It just knew, hey, here's some JavaScript files, take it if you want it. So in practice, the Create React App server was kind of simplistic, not a lot of complexity there. As you might guess, the situation with Next.js is a little bit more confusing. So let's talk about what's going on there. Next.js makes use of a process called server-side rendering. The idea of server-side rendering is that whenever someone accesses our Next.js server, the server is going to take our React application, and rather than just send all that JavaScript down to the browser, Next is going to try to render the entire React app itself. In other words, all of our JavaScript code is being executed on the Next server. That server builds up an HTML document, and then it takes that HTML document and it sends it down to the browser. The benefit to this approach is that our users end up seeing content on the screen much more quickly than when we were using Create React App. Just think about it. With this approach over here, this server had to take all that JavaScript, send it on down. We had to download that JavaScript. We had to parse it inside the browser. We're not doing that manually, but the browser is. The React app had to boot up and then render some content on the screen. And that all takes some amount of time to execute. If the React app was very large, like maybe 1 or 2 megabytes of JavaScript, that entire process could take potentially several seconds, especially if our users were on a poor mobile connection. However, with this server-side rendering approach, because the Next server is sending down a completely rendered HTML document, our content is going to appear on our user screen much more quickly, especially if our users are on a mobile device. So by using Next and using this idea of server-side rendering, we are ending up with an application that is much more flexible for a wide variety of customers or users in the world today who might be accessing our product off a mobile device with a poor cellular connection. Just so you know, after the next server sends down our HTML document to be rendered on the screen, it does shortly later send down all of our JavaScript code as well. After this JavaScript code is loaded up into the browser, the React app inside this code right here, this is our code base, then boots up and takes over inside the browser. So eventually the React app is booted up inside the browser, but the whole idea here is that before any of that occurs, we very quickly show some plain HTML content on the screen, just to get something on the screen earlier for our users. So you might be wondering, well, how does this all relate to the error message that we just saw? The error message that says, window is not defined. Well, let's think about it for a second. We just said a moment ago, our code gets executed on the next server. I want to go pull up one file that we wrote inside of our project so far, and I'm going to point out something inside of it. So back inside my code editor, I'm going to pull open the web3.js file. Inside of here, you'll recall that we took a look at this window variable. Window is a global variable that is available only inside the browser. Window is not available on Node.js, which is where our server is currently running. So in other words, whenever Next.js loads up our code in an attempt to render our React application on the server, that window variable is not defined. So we get that error message that says, hey, you're trying to access window, and that variable is not defined. And that's why we saw this big, nasty error message. It's because whenever the next server is attempting to render our application, we don't have access to that variable. Like I said, this is a really good segue, and it's a really good alert, because now we know that whenever we are writing one of our React components or some snippet of Ethereum code or whatever it might be, we need to be aware, or at least thinking about whether or not that code is going to be executed on the next server. Because if it is, that means that we cannot just freely assume that we have access to some objects or variables or whatever else that are usually defined inside the browser. So in short, long story short here, I know we've been talking about this for a while, the long story, the short story, whatever, is that we cannot directly access this window variable inside of this web3.js file. So we'll figure out a workaround to that in just a second. But before we do, there's one last thing I want to mention about this entire server-side rendering process. You might be thinking, Steven, geez, this server-side rendering stuff, where did this come from, right? Again, it goes back to the same thing we said earlier. You're here to learn about Ethereum, not React. Well, here's the thing. When we start thinking about Ethereum, we've been saying all along that we really expect our users to be running MetaMask inside their browser, right? We've been saying, oh yeah, we're going to use the provider that is given to us by MetaMask, and all is going to be well. But in reality, things usually end up not being quite so easy, right? Chances are essentially nobody in the world is running MetaMask at all inside their browser right now. Maybe at some day in the future, it'll be much more popular, but certainly right now, I really bet you like 99.9% of people out there are not making use of MetaMask. And that means we need to think about how we can make our application work for all those people who are not making use of MetaMask. So the big idea behind using Next.js is this. When our code is taken and rendered on the next server, we are going to reach out to the Ethereum network and do some initial calls. We're going to do some data fetching. We're going to try to get a list of our campaigns. We're going to find out details about each of those campaigns. We're going to load up how many votes, how many requests, all that kind of stuff. We're going to execute all of those requests from our server. And that means when we produce our HTML document right here to send down to the user's browser, it doesn't matter whether or not our users are using MetaMask. It doesn't matter whether or not they even have access to an Ethereum network, because we have already taken care of all that data fetching for them. And we are going to send them an HTML document with all that information already contained inside of it. So if our code ends up going crazy and saying, hey, MetaMask isn't here, I have no idea what to do, it doesn't matter one bit, because we already wrote all of that data fetching logic to be executed on the server. So all of our users out there who are not using MetaMask are going to very easily see some information on the screen. And as far as they are aware, they don't even know that MetaMask or Ethereum or Brinkby or whatever exist. They don't have to care one bit. So again, like I said, I know this React stuff and the Next.js stuff is a little bit annoying, probably unexpected in this course. However, really good reason that we're using it right here. This is why we are using it, because we cannot assume that our users are making use of MetaMask. Okay, so hopefully that answers a couple of questions. Let's continue in the next video, and we're going to get this window variable right here working whenever our code is executed on the server. So quick break, and we'll take care of that in just a minute. In the last section, we spoke about why we saw that error message about the window variable. Remember, this file right here gets executed 2 times, one time on the server to initially render our application, and then a second time inside the browser. When it is executed on the server, the window global variable is not defined, and that's why we see the message that says window is undefined. So in this video, we're going to do a little cleanup to this file, and we're going to make sure that this code can safely be executed on either the server or the browser. Now, explaining exactly what we're going to write here ahead of time is a little bit complicated. So we're going to first write out some code, and then it'll be a lot more obvious what we're going to try to do. I'm going to take this line of code that we already wrote, and I'm just going to delete the entire thing. We're going to rewrite it in just a second, but honestly, it's easier to just start off with a blank slate. I'm going to replace that with one variable declaration. I'm going to say let web3, like so. Remember, whenever we use the let keyword, it means that we want to be able to reassign this variable. Right underneath the let keyword, or that variable declaration, we're going to set up an if statement. We're going to do a little bit of comparisons with this if statement, and then depending upon which branch we enter into, we're going to assign a slightly different value to web3. So we're going to say if, I'm going to just kind of write out the statement first. And we'll talk about what each of these considerations are for. This first if statement right here, or the first kind of catch case right here, is going to handle the case in which our code is being executed inside the browser and MetaMask is available. So inside this if statement, we're going to do a check to see if we are running in the browser. To see if we're running in the browser, we're going to use a little bit of a trick here. So we're going to say type of window and then does not equal undefined. So in case you're a little bit newer to JavaScript, or you just haven't used type of a whole bunch, we can use the type of operator to see if a variable is defined. We're saying type of window. If window is defined and we are running this code inside the browser, we should see the string return from this of object. And as a matter of fact, we can flip over to the browser right now and test that out. So over inside the browser, if I open up my console, I can write, and let's get the font just a little bit bigger, I can write type of window. And when I execute that, I get back the string object. However, if I execute the same line of code inside of the Node.js runtime, I'll get back a string that says undefined. And we can very easily test that as well. If I flip on over to my terminal and enter the Node.js REPL by running the command node like so, this gives me access to a Node.js command line. Inside of here, I can freely write out some amount of JavaScript. And so over here, if I write out type of window, I get back the string undefined. So essentially, by saying type of window, we can very easily check to see if we are running code on the server or on the browser. All right, so back over here, this is checking to see if we are on the server or the browser. If type of window does not return undefined, notice how we are checking to see if it is not undefined, then that must mean we are in the browser. Now the second thing we're going to do inside of here is check to see if the user is running MetaMask. If the user is running MetaMask, then it should have already injected a copy of web3 on the window variable. So we can check for that in a very similar fashion. We can say and if window.web3 and we'll do the same type of thing here. So we're going to say type of window.web3 is not equal to undefined. So first we check to see if we are in the browser, and then we check to see if MetaMask has already injected Web3. So if we end up in this branch of the if statement right here, then we can say that we are in the browser and MetaMask is running. So in that case, we want to run the same code that we had in this file before. In that case, we want to hijack MetaMask's current provider and use it to create our own instance of Web3. And then we will assign that to this Web3 variable that we defined out here. So in total, we're going to write out Web3 is new capital Web3. Remember, this is our constructor right here. Then we'll take the copy of MetaMask, or excuse me, the copy of Web3 that was injected by MetaMask. A lot of just crazy terminology here. So we're going to say window Web3 current provider, just like we did before. So hijack that thing's copy of, or hijack that thing's provider and use it to create our own instance of Web3. And just as a reminder, you'll recall that we are doing all this right here so that we know that we are always using the same version of Web3. If we relied upon the copy of Web3 that is injected into the browser by MetaMask, we might be using like version 0.1 or version 0.20 or version 1 or who knows what, right? We don't know what version is being injected by MetaMask. We could always check, right? We could check, but hey, if it ends up being the wrong version, well then we're up a creek anyways. So no matter what, we're going to try to create our own copy of Web3 and assign it to this variable. Now in the else, we need to handle the other case. So this is going to handle the case in which we are on the browser or the user is not running MetaMask. In this case, we're going to do things a little bit differently. To handle this case, we're going to set up our own provider that connects to the Rinkeby test network through Infura. And you'll recall we've been using Infura quite a bit throughout this course to access the Rinkeby test network for our deployment script. So we're going to set up our own provider that works through Infura and then use that as the provider for our Web3 instance. And again, this is taking care of the case in which, and you know what, I just realized I made a typo here. I said we are on the browser. We are on the server, my mistake. So this is going to handle the case in which we are on the server or the user is not running MetaMask. Okay, so to create our own provider, we can say const provider is going to be new capital W Web3 dot providers dot HTTP provider, like so. So this is how we make our own provider. We call this function, and then we have to pass in the URL of some remote node that we have access to. So we're going to pass in the URL to the Infura node that we already signed up for previously. If you don't have that URL handy, that's totally fine. We actually already have a copy of that URL inside of our deploy.js file. So if we open up deploy.js, right here is the URL that we need. So this will allow us to connect to the Infura network, connect to the Rinkeby network through Infura, and this is our access key. You might be thinking, wait a minute, Stephen, we're going to let everyone in the world have access to the access key right here? Well, remember, right now, Infura is not used for storing any account information. It is solely used as a portal to access the Ethereum network. So right now, totally fine to share this key around, especially since it is free and you didn't pay any money to get it anyways. So no big deal. All right, we're going to copy this entire URL and we're going to paste it inside of here, giving it to our provider. So now we're making our own provider that is accessing the network through this URL. And then the last thing we have to do is to create our own instance of Web3 once again. So we're going to say Web3 is going to be new capital Web3, and we're going to pass in the provider that we just made. Okay, so that's pretty much it. So we're now handling the case in which we are in the browser and MetaMask is running. We're also handling the case in which we are on the server or the case in which we are on the browser and the user does not have MetaMask. hopefully now the reason that we did this initial assignment of, or this initialization of Web3 up here makes a little bit more sense. So we're defining Web3 out here. We then define it one way or the other. And then by the time we get to the export default statement, Web3 is holding an instance of Web3, either way. All right, let's save this file, and we're going to flip back over to the browser and see how we're doing. So back over here, it looks like we've now got our page being rendered. So I see the text up here, campaigns index. That looks good to me. However, if you have your console over here open, you might see a message that says campaigns is not defined. So chances are we have a little bit of a typo inside of our index file back over here. And you know what? I just saw it. Here it is right here. So we are taking our list of campaigns and assigning it to the variable campaign. So let's fix that typo really quickly. It should definitely be campaigns on both of them. Let's save this again and try testing one more time. So I'm going to refresh the page. And okay, so we don't have anything appearing on the screen, but we do have our address appearing down here inside the console. So this is the console log that we had just added. And this is the address of the campaign that we just deployed from Remix. So it looks like everything is working out pretty well so far. So let's pause right here. We'll continue in the next video, and we're going to make some changes to our component to get that address to appear on the screen. So I'll see you in just a minute. We are now able to get a list of all the different campaigns that have been deployed through our factory. This information is currently appearing on our console, and we definitely want to get it on the screen. So in this video, we're going to figure out how to take this data and use it inside of our React component to get it to show up. At present, we're doing that request, or that call to get deployed campaigns inside of the component did mount method. Now in any traditional or kind of typical React project, doing our data fetching inside of component did mount is 100% appropriate. So what we're doing right here, totally appropriate in a traditional React application. However, we are making use of Next.js, which introduces one little extra requirement around data loading. You see, in the last video, we explained server-side rendering and what it does for us. We had said that server-side rendering attempts to render our component on the server and then take all that HTML and send it down to the browser. The catch there is that if we want to do our data fetching, like if we want to do this step right here, where we have our next application reach out to the Ethereum network to get some initial data, unfortunately, Next does not execute that component did mount method on the server. So in other words, when our application is being rendered by Next on the server, this code right here, not executed, not one line of it. So if we want to make sure that this data fetching process right here occurs on the server, we have to move it to a slightly different method inside of our component. This method is called getInitialProps. It is a lifecycle method that is defined exclusively and used exclusively by Next.js. So getInitialProps is not used in traditional React. It is something very specific to Next.js. Let's take a look at a diagram to figure out exactly how it works. All right, so right over here. So let's imagine that some browser tries to visit the root route of our application. Next is going to boot up, and it's going to say, oh, okay, we need to show the campaign index component. The next server is going to look at that component, and it's going to find the getInitialProps function tied to it. Next is going to execute just that function. So it's not going to attempt to render the component yet. It's going to just render this function right here. After calling that function, we're going to return some initial data. So this will be any data we care about. It could be our list of campaigns. It can be the number of contributors on an individual campaign, whatever we want it to be. Next, we'll then take this initial data right here and provide it to the actual campaign index component as props on the server. This component will be rendered on the server. Next, we'll then take that component's HTML that is produced and send that down to our browser. So in other words, if we want to make use of the server-side rendering stuff, we have to do our initial data loading inside of this getInitialProps function. So let's define this function. we're going to do our data loading or our data call over to our factory contract inside there. And then we will be able to make use of that initial data inside of our campaign index component. All right, so back over here, we're going to first start off by defining the getInitialProps function. Now there's one little twist here, one thing that kind of makes life a little bit more interesting. When we define this, we're going to use one additional keyword when we define the function. We're going to say static getInitialProps, like so. Using this keyword right here of static defines a class function. So normally, whenever we use a class in JavaScript, we have to create an instance of that class to access any of the methods tied to it. For example, if I wanted to directly call the render method, I would have to say something like const campaign index is new campaign index. And then I could call on this little instance right here, campaign index.render. With a static keyword, this function is not assigned to instances of the class. Instead, the function is assigned to the class itself. So if we wanted to directly call getInitialProps right here, we would say campaign index.getInitialProps, like so. We do not have to create an instance. Now you might be just a little bit curious why Next requires that. So this is a requirement placed on us by Next. Well, it's very simple and very straightforward. Next wants to be able to retrieve this initial data without attempting to actually render our component. Rendering a component is a very computationally expensive process. So by skipping any initial rendering here and just directly calling that function, Next is able to make the entire server-side rendering process much more efficient. So that's why we are using that static keyword. Now, in addition to the static keyword, we are going to write some asynchronous code inside of here as well. So we're also going to put async on there too. All right, so now we can take the call to get our list of campaigns that we are doing inside of component.mount. I'm going to cut this line of code and I'm going to put it inside of getInitialProps. And then from getInitialProps, I'm going to return an object. And that object is going to be provided to our component as props. So right here, I'm going to say simply return campaigns is going to be campaigns. And once again, ES 2015 code, we can condense this down to be simply campaigns. Last thing we need to do is delete the old component.mount. All right, now that's a fun refactor if you ask me. So now, whenever our component is rendered, getInitialProps is called, we fetch our list of campaigns, we return the object. This object is provided to our component as props, and now inside of our component, we can freely reference this.props.campaigns. So for example, let's take our div right here, and we will replace the text with the address inside of this campaigns array. So to access that thing, we're going to place our curly braces and then say this.props.campaigns. Again, we have access to the campaigns property right here because we returned a property on this object called campaigns. That's going to be our array of addresses, and I want to print out the very first element inside there. So I'm going to say, just give me the first address because there's only one. All right, let's save this file and flip back over to the browser and see how we are doing. All right, so back over inside the browser, I'm going to entirely refresh the page. And sure enough, our address appears on the screen. Now, one thing you might find really interesting to test the server-side rendering aspect of this, because this component is rendered both on the server and once everything loads up, it's executed on the client as well. So we can test exclusively the server-side rendering aspect of this by disabling JavaScript execution inside our browser. So that's going to keep the React app from loading up in our browser, and we can confirm that Next is successfully fetching this list of campaigns. We can do that by clicking on the little I right here, and then where you see JavaScript, we can change that to always block on this site. So now JavaScript is not being executed on this page, and if we refresh the page, you'll see that the address is still going to appear on the screen. So here it is, here's the address. And that's because our server executed the call to our contract to fetch this address right here. That's really great news, because that means that if someone on a very slow mobile device or someone without MetaMask or who knows what type of situation tries to access our page, they're still going to see some content appear on the screen, which is exactly what we want to make sure of. All right, so this is definitely working out pretty well. The last thing I'm going to do is make sure that I re-enabled JavaScript. So I'm going to click on that I again. I'll find JavaScript and I'll change it to use global default. And then once again, I'll refresh the page just to enact that change. Okay, in the last couple of videos, we have learned a lot. And as I've said at the start of this section, we're kind of diverging away from Ethereum a little bit. I can't say it enough, however. All the stuff is so incredibly interconnected. And if you want to build a quality Ethereum app, you have to do stuff like the server-side rendering stuff that we're doing. It's just comes with the territory. It's a part of the ecosystem. Hopefully it's not that bad. Maybe you're really enjoying this and I'm just thinking that you might not be enjoying it. I don't know. Anyways, I think our application is turning out pretty well so far. This might all seem a little bit complicated, but honestly, at this point, we have covered like 90% of everything that we really need to know about React and everything we need to know about Next. So essentially from here on out, we're just going to be doing the same thing over and over and over, getting some initial data inside the getInitialProps function, and then printing that out on the screen somehow. So pretty much the same thing from here on out. So we'll get a lot of practice with both React and Next and Ethereum, of course. Let's take a pause right here. We'll continue in the next video and continue working on our application. We've now got a great idea of how to fetch data and get it to appear on the screen. Like I said in the last video, from here on out, we're essentially going to be doing the same thing in a pretty repetitious fashion. So now we can start thinking about how to actually get information to show up on the screen, and we could spend some time on styling and all that kind of good stuff. As a quick reminder, right now we are working on a component that should eventually look like this right here. So I want to show a nicely formatted list of all of our campaigns. I should see a button on the right-hand side where we can create a campaign and all that kind of good stuff. Now you and I could definitely spend a lot of time working on CSS and making this look good. But rather than wasting any time on that, I think that we should probably use a component kit to help us out with the styling. We're going to use a React component kit called Semantic UI React. This is a library that comes with a bunch of pre-created components that we can very easily get access to and use inside of our application. The benefit of all these components is that they come with styling already placed on them. So you and I won't have to do a bunch of CSS work to get our application looking really good. And trust me, the final product is going to look really cool. So we're going to install Semantic UI React inside this section, and then we will get a good sense of exactly how to actually use it inside of our project. Now, I know I've said in the last couple of videos like, yeah, so many technologies. And so you're probably sitting there now thinking, what, you're going to add another technology? That doesn't make any sense. Well, trust me, this time around, it definitely makes a lot of sense here. Semantic UI is such an excellent project. It's going to really make our project look awesome without a lot of additional work from us. So let's flip over to our terminal. We're going to install Semantic UI. I'm going to go to the tab that is running our server right now. I'm going to stop that server by pressing Control-C. Then we can install Semantic UI React by running the command. And let me get the exact package name here. All right, we want npm install -- save semantic UI React, like so. So semantic UI React, all separated with dashes. All right, while that's installing, let's go and look at some of the documentation around this package so you can get a really good idea of how it works. It's a really great package, and I suspect you will probably eventually want to use it on your own personal projects. So in a new tab, I'm going to search for Semantic UI React. And we'll give it just a second to load up here. Here we go. So I'm going to find the first result here, which should be at react.semanticui.com. So this is the documentation for the project. All right, come on, let's go. There we go. All right, so on the documentation, we get great examples of all the different components that are available to us. So on the left-hand nav over here, you'll see a listing of all the prefabricated components that we can make use of. Let's take a look at, for example, maybe the button element. Start nice and simple. When we look at button, you'll see a list of all the possible properties that we can pass to a button component, as defined by the Semantic UI React package. So this is all the different properties we get access to. And in total, it's pretty much covering the entire field of how you ever might want to be customizing a button. A little bit underneath that, you'll then start to see some examples of the button component. So here's an example of the button that we get for free from Semantic UI React. This is the most basic button that we can possibly create. I think you'll agree with me that, yeah, it looks pretty reasonable, right? I think it's going to work really well for our project. If you keep on scrolling, you'll see a lot of other examples inside of here of how that button can be customized. So all the stuff that you see in here, you can easily do with Semantic UI React. All the stuff that we're scrolling through. To get a good idea of how any of these examples can be written out, you can hover over the example. Let's go back up to the top one right here. So I can hover over the example and you'll see these buttons on the top right appear. If you click on Edit Code, it'll pop up a little editor and it will give you a very simple demonstration of how to create exactly this component right here. So to create a button, we're going to import button from Semantic UI React, and then we can use that as a component, just like you see right here. And so if we want to, we could even customize the text. We could say, I don't know, please click me, and it customizes it right there. So yes, Semantic UI React, it's totally awesome. It's a great project. It's going to really improve what we are doing here. We can see other examples over here on the right-hand side. I think our project is going to eventually make use of, I believe, table. So we can take a look at, say, table, and it will give us an example of a table component. And just as before, you can click on the little code button and it will give you a great sample of exactly how to get exactly that content right there. Okay, so that gives us a little bit of a better idea of how Semantic UI works. Let's take a pause right here. We're going to make sure that everything installed successfully. It looked like it did. So let's continue in the next video, and we're going to put that package to use inside of our campaign index file. So I'll see you in just a minute. In the last video, we installed Semantic UI React into our project. Before we move on, there's one little oddity around the installation of this module that I want to point out. I'm back in the documentation on the usage page right here. At the very top, you'll see directions on how to add the module. In this case, they're saying, hey, use the yarn package manager, which is more or less equivalent to NPM, which is what we've been using. The directions here clearly say, oh yeah, run this command, add the module Semantic UI React, which is what we just did. But what's a little bit misleading is that when you install this module right here, all you are getting is code to create these different components that are listed inside the module. What's missing from this is the actual CSS that makes all these components look nice. So by default, this module right here just gives you big blobs of components, a bunch of components that you can render onto the screen, but it's just the markup and you don't get any styling for them. So if we used any of these components right now, they would show up as very plain looking, boring text, and they would look awfully strange. So we have to go through one additional step to actually include some CSS into our project as well. If we scroll down this page a little bit further, you'll see another section called CSS. So this is all the different ways that we can include the Semantic UI CSS into our project. We can either add in this link tag right here, or we can add a separate package called Semantic UI CSS and then import that somewhere into our project. We're going to use this methodology right here just because it will allow us to skip having to add in a link tag. So let's go back over to our terminal and we're going to install this module as well, Semantic UI CSS. Back inside my project directory at the terminal, I'll run npm install -- save Semantic UI CSS. All right, so we'll let that do its installation, and we'll come back in just a moment and make sure that we add in this import statement. But while that's installing, let's talk about where we're going to immediately start to use this Semantic UI package. If we go and look at our mockups one more time, you'll recall that on this initial landing page, the page that shows our list of campaigns, we want to show a couple of different boxes, where each box is supposed to give some details about one campaign that has been created by our factory. At the top of the box, we want to show an address, and then underneath it, I want to show a link that allows a user to go and navigate over to look at that particular campaign. So let's go back to the semantic UI documentation and see if there is any component over there that allows us to kind of make something that looks like this. All right, so let's go back over. On the left-hand nav, I'm going to scroll down a little bit to the section called Views, and then inside there I'll find the card component. So here's the documentation on the card component. We're going to be using this component quite a bit throughout this application. It's kind of a multi-use component that allows us to make nice little looking boxes, add images, format them nicely, all that kind of good stuff. So we're going to get pretty familiar with this card component. In this case, because we want to show a list of different boxes here, or a list of different cards, we're going to use a specific subcomponent in this thing called card.group that you see right here. So I'll click on card.group. The purpose of this thing is to display a group of cards to the user, and we'll see exactly what a card looks like in just a second. If you are all curious, this is a list of all the different props that we can pass into this component, but of course we'll go through these in great detail in just a little bit when we set up our first group. So I'm going to scroll down just a little bit and we'll get a better sense of what a group of cards looks like. All right, so here's a good example right here. So this is essentially what we want our landing page to look like. At the top of each card, I want to show the address of a particular campaign. And then underneath that, in this kind of content area right here, I want to show a link that a user can click on to go and visit that campaign. We're not going to be using any of this grade text right here, so we don't have to worry about placing that grade text. If I hover over this section, remember we can get this little code icon right here. So I'll click it and we'll get a good example of how to create a card group like this. So here's the code snippet right here. Let's break this down piece by piece. At the top, we import card from Semantic UI React. Next, we create an array of what they call items. Every item is an object inside this array, and every object represents one card that will be created and placed on the screen. Every one of these objects is supposed to have a defined set of properties tied to them. So if we add a property to each of these objects called header, that text right there will be used as the header text inside the card. So in this case right here, you see project report April. Yep, there's the text right there, project report April. So the header property is used as the header text, and the description property is used as the description text. So leverage agile frameworks, blah, 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 leverage agile frameworks, and so on. So I think that what we need to do is to take every one of the campaigns that you and I fetched from our campaign factory. We're going to take that array of addresses. We're going to loop over it, and for every address, we're going to build one of these objects. Each object is going to have a header of the campaign's address, and then the description will be a link that can take the user over to visit some details about that campaign. So essentially, we have to take that array of addresses and transform it into an array of objects. After we create that array of objects, we can then place the card.group component somewhere inside of our component, and we'll pass in that array of items or that array of objects as the items property. And that should then get our group of cards to appear on the screen. Okay, so let's take a pause right here. We'll come back to the next video and we'll start implementing this card group component. In the last video, we spoke about the card group component that is included with Semantic UI. Let's now flip back over to our code editor and try implementing this inside of our campaign index component. So back over here, I'm going to create a new function that we will use to create this card group component. I'm going to add a new function called render campaigns to my component. Then inside of here, we're going to iterate over our list of campaign addresses. And for every separate address, we're going to create a different object. each of those objects will represent one individual card. So they will have the header property and the description property. So back inside of render campaigns, I'll say const items, just like we saw in that code snippet over in the browser a second ago. We'll then iterate over our list of campaigns by using the mapping function. So I'll say this.props.campaigns.map. Remember how a map works. We pass a function into map. That function will then be called one time for every element inside of this array. That function we pass in also gets called with each element in the array. And then whatever we return from that inner function will eventually be assigned to the items variable over here. So inside of the map function, I'll add in address and then our arrow function. And inside this, we're going to assemble one individual object to represent one individual card. So we'll say return our object. It's going to have the header property, which is going to be the text that we want to display as the header of the card. And for that, like we saw in our mocks just a second ago, we want the very top text in the card to be our campaign's address. Then underneath that, we want our description property to be a link to go view this particular campaign. Now we haven't discussed how to navigate between different pages with Next.js just yet. So rather than going into that very deep, long discussion right now, let's just add in a temporary solution. I'm going to put in an anchor tag without any href property or anything like that. And we'll come back later on and learn a lot more about how to work with navigation. So right now we'll just give it the text view campaign, like so. Now I am going to add on one additional property to this. We'll add the property in and then we'll talk about what its purpose is. So I'm going to say fluid is true. So what is this for right here? Well, if we go back over to the example inside the browser, you'll notice that this group of cards right here appears to have some arbitrarily constrained width to it. In other words, the width of this card doesn't appear to automatically stretch over to the far right hand of its container. By adding on that fluid equals true, fluid is true property, it causes our cards to look like what you see right here, where every card is going to stretch the entire width of its container. And if we think back to the diagram or the mock-up that we were looking at earlier, that's definitely what you and I want. So we want this thing to stretch from the far left-hand side to the far right-hand side. But of course, it's not going to interfere with or somehow kind of impact this create campaign button that exists on the right. So that's why we're adding on the fluid true property. So this statement right here is going to give us our list of objects where each object represents a single card. So now we can use this items array to create our card component and return it from this render campaigns function. So I'm going to say return card.group items items, like so. And then let's not forget that we have to add an import statement for the card component to the top of this file. So I'll scroll back up to the top and I'll add an import statement from card, or for card I should say, and don't forget the curly braces here because we are importing just one component out of the React Semantic UI library. So we're going to import that from Semantic UI React, like so. Now the last thing we have to do is make sure that we call that function from our actual render method right here. So we don't want to be just printing out the first address anymore. Instead, we want to show this big list of nice looking cards to our users. So I'm going to replace this.props.campaigns at 0. I'm going to leave the curly braces in here because we're still going to make a function call, or we're still going to reference a JavaScript expression. And inside there, we'll say this.renderCampaigns, like so. All right, let's not forget to start our application back up at the terminal. So we just killed the terminal a moment ago when we installed the Semantic UI React module. Remember that to start our application back up, we can run the command npm run dev. So we'll execute that. We'll wait just a second for everything to boot up. And in just a second, yeah, there we go. So we'll see compiled successfully. So let's now go back over to our browser. I'm going to refresh the page manually. And after just a moment or two of boot up, we'll eventually see some content appear on the screen. All right, there we go. Okay. So that's kind of interesting. The content definitely updated. You see how we have the address right here? However, we have view campaign as well, so we definitely know the changes that we just made went in and went into effect. However, we don't have a nice looking card like we saw in the Semantic UI React documentation. So clearly something is not quite going on correctly here. So let's take a quick pause. We'll come back to the next video and figure out exactly what's going wrong. In the last section, we got an update to our component right here, and we can definitely tell that we are successfully using the card group component because I see the text view campaign on the screen right here. If our component was not working correctly, we would have not seen that text appear at all. So let's figure out exactly what's going wrong here and how we can fix it. This is a little bit of a gotcha around Semantic UI React. If I flip back over to the documentation and then go up to the very top and click on usage, you'll see that this first section right here says, oh yeah, you can install all this stuff by running yarn add. And just so you know, if you're not familiar with yarn, it is more or less equivalent to npm, which we've been using. So it says, oh yeah, just install this module and you're good to go. However, if you read very carefully on the sentence right after that, it says you'll also need to include a style sheet to provide the styling for your components. So what we installed 2 sections ago was just the JavaScript side of Semantic UI React, just the component files. We did not get along any CSS or styling along with that module. So to actually get some styles, we have to do a little bit of additional installation. If you scroll down just a little bit, you'll see it listed here. So there's a couple of different ways that we can get some styling included in our project. We can either add in a simple link tag, or we can add in a Semantic UI CSS package. So this is a separate package that includes all the CSS included with Semantic UI. Normally, this would be the easiest way to get started. However, we are using Next.js, and out of the box, Next does not have support for CSS modules, as this is recommending right here. So we could use this by adding in support for that to Next. However, that's just a whole bunch of additional configuration that we probably don't want to go through because, hey, at the end of the day, we're here to build an Ethereum application, not learn about how to handle CSS. So rather than going through this extra step right here, we're going to keep things really straightforward and really simple, and we're just going to directly use this link tag right here. So I'm going to copy this link tag, and I'm going to go back over to my code editor. Now, as you and I very well know, and this is something we probably learned back in HTML 101 when we first got started learning about web development, we always add those link tags to the head tag of an HTML document. However, whenever we are using Next.js, we do not really get easy access to our default HTML document. Instead, Next automatically generates one for us. We certainly can customize how that gets generated. However, again, that's a little bit of extra hoops that we have to jump through to customize that document. And again, I don't really want to go through that entire big side topic. So for right now, as a very temporary solution, so this is something that we're going to come back to later on and fix and do it essentially the right way. But for right now, just to get everything to appear nicely on the screen, I'm going to take that link tag and just add it directly to our render method, like so. So you've probably never seen this before, a link tag inside of a React component. Well, don't worry, there's no reason we can't do this. Our React component will render the link tag, and that will cause our browser to download that CSS file just like it normally would. Again, this is a very temporary fix, and we're going to come back to this and address it in a more reasonable fashion. But for right now, I really just want to get some content working. So I'm going to save this file, and then we'll go back over to the browser and test this out. Once we go back over, our automatic module reload should kick in, and we should see a nice looking card appear on the screen. Okay, so this is much better. We definitely have some styling here. We've got the address of our campaign and a link to go view it. Of course, the link doesn't do anything just yet, but that's something we'll fix in a little bit. You'll notice that this card does in fact appear to be stretching from the far left-hand side to the far right-hand side. there's no margin between the sides of the browser and the card, and there's no margin at the top. So we can't quite get a sense of the card just yet, and clearly there's still a little bit of work we have to do on styling, but this definitely works for right now. So let's pause right here and come back to the next video and continue working on this campaign list component. In the last section, we finally got a campaign to appear on the screen. Right now we only have one campaign tied to our factory, but we will eventually go back and create more campaigns so we can see a full list eventually develop here. Remember, we wrote out that render campaigns function to assume that we have multiple campaigns. So as we start to add more, we should definitely automatically see them appear on the screen. We'll eventually add those campaigns, but for right now, I want to continue working on the campaign index component. Let's go and take a look at our mockup really quickly. So back over here, all right, well, we've kind of got this part done. So let's start working on the right-hand side, which is where we should show a big button that says Create Campaign. So a user should be able to click this to go to a page where they will make a new campaign. Rather than creating a button manually ourselves and adding in some CSS and styling to it, we will instead again use the Semantic UI React package to create a button for us. So let's go and look up some documentation on how to make a button. Back over here, I'll find the Elements section. Underneath that is the Button section. I can scroll down a little bit, and I'm going to look for a section that says Icon with Label. So right around here, Labeled Icon. I think that this would be a pretty good component to use to show a user a button to go and create a new campaign. I think that we should put an icon with like a little plus or something so that the user understands that they can click this to add something to the application. Let's again expand this little code section to see what's going on. Now notice that there are two code sections here if you're following along in the documentation. So there's like this first section and then a second one right here. The first section shows kind of like a long form way of creating a button with an icon. So this long form way is to create a button component and place an icon component inside that. But we don't really want to use the long form way because there's a shorthand way. And in general, we always like using the shorthand or more compact form. So with this approach, we can use a button component. We can pass in a content property, and that will be used as the text, and then the name of an icon to use. Semantic UI ships with a collection of different icons that are automatically included. So all we have to do is use the correct name of an icon, and Semantic UI will automatically place that icon inside the button. I'll eventually show you where you can get a list of all these different icons, but we'll come back to that in a little bit. So I'm going to go back over to my code editor, and we're going to start to add this button in. I'll start off by going to the very top where we are going to add an import statement for the button component in addition to the card one. I'll then go back down to my render method, and right after we render out our list of campaigns, I'll place the button. Now I expect there to be a couple different properties that we're going to assign to this, so you'll notice that I'm going to make a self-closing tag that spans a couple of different lines. Then inside of here, we'll first start off by specifying the content property. So for content, we're going to say that this thing should say something like, I don't know, create campaign. I think that works. Next, we'll specify the icon property. So this is the icon that we want to use inside the button. Like I said, there is a collection of very specific icon names that we can look up inside the documentation, so we can know exactly which icon we're trying to add here. Now I've already gone and looked up the appropriate icon name. The one that we are going to use is add space circle. So that's going to make a little plus symbol with a circle around it. And it's going to essentially look like a button that you can click on to add something, more or less. We're going to add one additional property to this thing. We're going to add on just the text primary. So if you are a little bit newer to React, just so you know, you don't always have to specify props by providing the property name and then saying equals something. If you are trying to pass in a property with a value of true assigned to it, like that, you can do a little shorthand abbreviation by just listing out the property name. So by saying primary like this, it automatically gets expanded to be primary equals true. So let's really quickly look up the documentation for what this primary flag does. If I go back over here, I can scroll up a little bit and we'll see a good example of that primary property. So under emphasis right here, by adding on property, by adding on primary, all it does is add some nice blue styling to the button. Adding a campaign is definitely like a primary action inside of our application. So yeah, I think using primary right here is a very reasonable way of styling the button. Okay, so let's go back down. I just want to make sure we got all of our markup right. So yeah, I think we got everything. The label position, I believe, is a optional property that kind of positions the label on either the left-hand side or the right-hand side of the button. It is optional, so let's try not adding it right now, and we'll just see what happens, and if we need to add it, we'll come back and do it. All right, so I'm going to go and make sure that I've saved my index.js file. I'll then go back over to my browser, and sure enough, it looks like we get our campaign to appear, or the button to appear. Now you'll notice that by default, it has the nice kind of like circle plus icon button right there. If we want to try a slightly different icon, we could always change the icon to instead be just like add. So if I now save this, we'll get a nice little plus right there. So you can go with either icon, it's totally up to you. And like I said, in just a little bit, I'll show you where you can reference a list of all the different icons we use. So you can change it further if you want to. But I'm going to leave mine as add circle. And okay, so that looks good. All right. Well, we definitely have the button showing up here, but you'll recall that inside of our mockup, we had really wanted to see that button appear on the right-hand side of the screen. So I think we still have a little bit of work to do there. We're not going to accomplish this just yet. There's one or two other quick things I want to do inside this component, but we'll take a pause right here and we'll continue with that in the next video, and then eventually we'll come back and make sure this thing moves over to the right-hand side. So quick break, and I'll see you in just a minute. On our campaign index page, we are now rendering out a list of campaigns, and we've got our button over here that the user can eventually click on to go and create a new campaign. Like I said previously, we haven't discussed navigation just yet, so we're going to come back to this button and make sure that someone can click on it to be taken to this other form where they will make a campaign. But again, that's something that we're going to come back to. Before we tackle that, I want to address one or two open issues in our campaign index component. First off, and this is a kind of easy one, I want to make sure that the top of the page has this nice open campaigns label. That's really easy to do. That's not going to be very challenging. But the other thing that we need to address that is a little bit harder is making sure that we can display a header on this page. One thing that you'll notice about the header up here is that it needs to not only appear on the campaign index page, but it also needs to appear on basically every other page that we have inside of our application. So we need to make sure that this header can show up everywhere. Now let's first take care of this little label right here, and we'll come back and talk about how we address that header. All right, so back inside my code editor, I'll say that just right above the render campaigns method call, I'm going to add in an h3 tag, and we'll give it the text open campaigns, like so. Now I'm sure this is going to work out just fine, but very quickly, we'll go and check it out inside the browser, and yeah, that looks just fine. Okay, so now we've got that easy part done. Let's start thinking about the header that we have to get to show up. Now, because this is some element that we want to show on every single page inside of our application, it definitely seems to me like we should not be attempting to recreate the header inside of every page component that we make. In other words, I don't really want to go into every page component that we eventually create and have to manually say like, okay, let's make a div and it's going to have like the text Coinbase on the left-hand side and then like, you know, campaigns on the right-hand side. So I obviously don't want to be doing that again and again and again. Instead, I think that we should definitely create one single header component and make sure that is used across all the different pages inside of our application. But you know what? I want to take that idea one step farther. So we know that we definitely have a header component on every page. And you know what? It's probably not completely unreasonable to assume that we might eventually want to have a footer as well. You know, I'm saying maybe the footer looks identical here, but of course it would probably be a slightly different looking footer. So even thinking about kind of extracting or making a separate component for the header, I still don't want to have to come back into every one of these page components and place a header at the top and a footer at the bottom. I don't want to have to type this again and again and again. So it'd be really nice if we could figure out some way to have some common styling or some common elements across every page inside of our application. Now here's the good news and bad news. The good news is that we can definitely do that. We can figure out a way to have some common elements shown on every page. The bad news, there's always bad news. The bad news is that Next.js unfortunately does not make that the easiest thing in the world. It's just a little bit challenging to put that together. So let's talk about exactly how we're going to approach this. Now, as you very well know, because we've been discussing it nonstop, inside of our project, we have that pages directory. And every file inside that directory eventually ends up as being a separate visitable page for our users. And so we are saying that every one of these page components, we want to have a really easy way to get both a header and a footer injected in there. The problem is that it's not super easy with Next to get some common element or some common React component to wrap or kind of inject some common React component into each of these. So we're going to use a little workaround that at the end of the day is very easy and straightforward, but it's just something that kind of has to be explained so you understand what's going on. So here's what we're going to do. We're going to make a separate directory called components. Eventually, we're going to put a bunch of different React components into this thing that are used over all of our application. Inside this components directory, you and I are going to make one component called layout.js. The purpose of this layout is going to be to house some very common elements that we want to display on every separate page of our application. So for example, if we have a header, we'll display the header inside of here. And if we have a footer, we'll show the footer as well. We'll then import this layout component into every single one of our page components. And we will display that layout component inside there. Now that might not sound like it's going to save us a ton of time or something like that, right? It sounds like, hey, we still have to write this extra component in every one of our pages. But the idea here is that by having a single layout file, we can add all of our repeated components. So like the repeated headers and the footers and maybe a sidebar or whatever else. All these common elements can be added to this one layout.js file, and then we will eventually use that in every one of the pages. So if we ever want to get some repetitive element to show up on every single screen, rather than going back to every single page component, we can just go and add it to the layout. And that's it, just one spot and we're done. Okay, so that's pretty much it. Let's pause right here. We're going to come back to the next video. We're going to make this components directory. We're going to make the layout.js file and then make sure that we use that inside of index.js. So quick pause and we'll get started in the next video.